Okay, so let's talk now about how you can set up your malware lab for malware analysis. Okay, so what do you need? First of all, guys, you need virtual machines. You will never ever run malware for analysis in your own machine. And in our case, when we are dealing with Windows based malware, definitely we need to run this on virtual machines. And that's like a rule of thumb. A virtual machine is different type of virtual machines. We're not going to go into that detail, but basically you have the host, which is your own machine, and then inside your machine you create other uh, operating systems, virtual machines. That's why it's called virtual machines, like new Windows operating systems, where you can operate and run your malware, but it is in an isolated environment. Okay, that's the reason that you use virtual machines. Uh, there are many out there. I highly recommend VMware. It has a player, VMware Player, which is free. Uh, if not, you have VirtualBox, is the one that is totally free from Oracle. First option. And you can also run Kemu, which is a Linux based, totally open source. So these two guys are free in case VMware Player is not. But VirtualBox is the one that we're going to be using here. Now, it's recommended if you can have a host, a Unix base, a Linux, and the virtual machines on Windows. But it's not actually simple because you need to have a Linux machine doing your job. And normally you have a Windows machine or a Mac OS machine. So if you can have a Mac OS machine, you can afford it. That's great. But if you're working in a company, that's definitely you need to ask in the company to give you a Linux box, and inside the Linux box you create virtual machines on Windows operating system, and that way the reason I'm telling you this is because if for some reason the virus gets out of the Windows virtual machine, it won't infect the Linux machine because it's totally different format. Okay, that's recommended, but not be too worried, to be honest. You can have a Windows machine, but definitely a Windows virtual machine to run the malware. I'm going to give you also some recommendations to be safe. The virtual machines must be in a segregated network. In a company, obviously, whatever is running this lab of analysis, these virtual machines in this segregated network, it will definitely be separated from corporate network. Hidden public IP, that means it depends, guys. If you are like an antivirus company, Kaspersky, Symantec, those guys, normally you don't want to have your IP revealed so that when you analyze it and when you visit the CNC and those things, the attackers doesn't know is you, the Symantec of those guys. It's up to you. It's up to me. I don't really care. But sometimes the companies can do that. And now that you work from home normally, there is a lot of home office work. It's a VPN is recommended. It's not like an attacker is gonna come and attack you. Might be, but it's not something normal. Firewalls, obviously, to segregate your corporate from your malware lab. You can automate these virtual machines. That's actually pretty cool because when you run this malware in this virtual box or VMware, eventually you are going to be running many malware, and then you can actually script it. You can have a command line so that you can go put the malware inside the VMware, inside the virtual box, and run it automatically and do the full analysis, dynamic analysis, which is this module. And then once you have a new one, you can just run it. You don't need to go click on the machine, open it up, load it, copy the malware. It's too tedious, So it can be automated. That's also pretty cool. It's scriptable. That's the term. It can be scriptable. Snapshots, very, very important. Snapshot is basically in the virtual machine, you can be working and then eventually you can take a screen and snapshot. That means you take you store the state of the machine at that moment. That's very useful for many reasons. I'm gonna give you a couple of examples. So first of all, when you have your virtual machine clean, totally clean, so you really wanna have the first snapshot. Why? Because once you run the malware is gonna infect your machine. Okay, and then once you are done analyzing it, you need to return. You just return to that snapshot when the VM was clean, and that's it. You're ready to start the next analysis. Otherwise, you will have your machine already infected, and not only can be dangerous, but also sometimes when you are doing analysis of traffic, mainly, you are gonna see malicious traffic, but probably it's not gonna be from your virus 1, virus 2, or virus 3. You're gonna be like, this traffic, who is sending this traffic of all those malwares that I'm running? And you can get confused, right? That's why first snapshot is very, very important. Not only that, also snapshots are very, very useful when you are doing an analysis. You will see that in the labs. So normally, sometimes when you are analyzing a malware which is taking too much time, sometimes it takes you even days. It depends on the experience. But sometimes you get to the point where you imagine that you do the analysis and eventually you are able to dump the malware from memory, but you already spent, let's say, 3-4 hours, and then you were ready. You were able to extract the malware from memory and get to the second stage in memory, and then suddenly, boom, the malware just exits, and at that moment, all your effort, all your 4 hours, 8 hours effort is gone, because now you lose the control. Now the malware is gone. The snapshot at that moment is critical, because you can say, okay, at this moment that the malware is already in memory, that I already get into the second stage, I put in a snapshot, and if eventually after that something happens, whatever happens, that the malware gets exit, or the malware gets corrupted, or whatever happens, and then just destroy your analysis, you can come back to that stage and keep analyzing. That's very, very useful, because then you will have, this is very useful when you have like multiple days doing the analysis. So you don't want to start over, from the step one. You always want to keep saving snapshots all the way when you get a really good finding during your analysis, so that you can return to the previous step. Another example, very, very common, you're going to be seeing. Sometimes you put a breakpoint in your debugger. You're going to see that in other modules, in our classes. And then you put a breakpoint because you think that the malware is going to run and stop inside the debugger in a breakpoint. But it never hit the breakpoint, and eventually, your machine gets infected. At that moment, everything is lost. And again, you put a snapshot before running the malware, and if something happens, you just come back. So at the end of the day, guys, snapshots is just a beauty, and that's why VMware, the player, keep in mind, check the player, because if I remember well, the VMware is commercial, first of all, and the player, I think the player is free, but I think it doesn't have snapshots. That's why I said your first option is VirtualBox, guy, for sure, for sure. Okay, so let's get to the last one, which is analyzing malware. Analyzing malware, I'm gonna show you tools that are used for dynamic analysis that, again, you guys are gonna be learning during the classes, okay? First of all, the sandbox. Sandbox are machines that have many different tools inside to analyze the malware while it's running. They can give you what it is doing at the file system, what it is doing at the network level, basically. Okay. Back in the day, there was a really cool sandbox called Cuckoo. This was pretty cool because it was open source and you can run it in your own infrastructure, and you can just customize it, and pretty cool. It has been discontinued lately, But the good news is that it's coming back again. So just keep a track of this link. It's there. I mean, you can use it, but it was discontinued, but it's coming back. So take a look at Cuckoo, definitely. A hybrid analysis, that's more commercial one, but it has an option, and used to have, keep in mind that you need to visit it and review it. Sometimes these guys remove those perks, but it used to have an option for you to just upload your malware and run it. VirusTotal allows you to upload malware and to see if it is detected, and gives you some visibility to some sandboxes. VirusTotal has like 5 sandboxes, but the commercial version, you need to pay for that, but still the free version gives you some visibility. So take a look, definitely VirusTotal. What are the benefits of Sandbox? Again, it's quick analysis. This runs not in your VM, as I just described before. You don't need to run this in your own VM. You just upload it to the internet, and you get back all the indicators. You get back all the activity performed by the malware. The only thing here, guys, to keep in mind, very, very important, is that if you work for a company, imagine that you find a malware in a customer, right? And that malware, you don't wanna upload it to internet, because that malware might have specific actions for your customer. So that's the only reason that sometimes sandboxes, you don't really want them, you don't wanna upload the malware there, okay? You wanna keep it inside your infrastructure, and that's why Kuko or other options can help you. There are some sandboxes that also have an option so that you can upload the malware, but make it private so that it cannot be available for everyone else. Like VirusTotal. If you upload something in VirusTotal, it becomes available for everyone. That means that if the malware gets uploaded and it has, let's say, attacking the product ABC from your company, immediately everyone, or I mean, whoever is analyzing in VirusTotal, they will realize there was an attack and it's a leak that you don't want to let everyone know, okay? But again, it's quick analysis. You will get reports in the network. You get strings, which is like strings on names inside the malware from memory that can give you a clue of what it is doing. Drop files, which is files that were loaded after running the malware, which are the ones that normally are being downloaded from internet. Those are the ones that you want. IOCs, as I said, pickups, which is files that capture the traffic for you to analyze. So it's quick benefit. It supports multiple operating systems. You can run it in multiple windows, so that sometimes malware runs on specific versions. The drawbacks is that sometimes malware requires some parameters to run, and that means that when you send it to these sandboxes, they cannot run it because the malware says, "Hey, I need a parameter to run, and I don't receive it." So I didn't receive it, sorry. So it won't run. And those, it's just back and forth drawbacks. And it's not an in-depth analysis, it's gonna run, but sometimes it won't run at all. Sometimes the malware is smart enough to know it's being run inside a sandbox, and it just won't run. So that is the reason when you need to do static analysis, reverse engineering, which is other modules that we're gonna be seeing also. Quick look in the hybrid analysis sandbox. You can have here, hybrid in the right side. You get the executable, you get network traffic, you get who is contacting, you get the strings extracted, you get all the files dropped in the system. And it's a huge information there that you can use. In the left side, you have Cuckoo that also has all these modules. You see, you can have behavioral, what it is doing in memory, where it is connecting, what files are dropped into the system, many other options. But these guys are very, very useful for dynamic analysis, definitely. Another point that I want to talk about is not only executables, it's also DLLs. Again, here is high level because eventually you will see it, but if you remember in the module 1 of Windows binaries, we talk about DLLs, dynamic load libraries. Basically, those cannot be run by itself. Like an executable, you double click on it and it runs. A DLL needs to be loaded by an executable. So if you have a malware which is a DLL, you cannot double click on it and run it. But then how you run DLLs, that's also something that you can also do through sandboxes. Some sandboxes has the option to run DLLs. They can create what is called a DLL loader, and they run it for you. You can also run it through a command in Windows called run DLL. So you basically put the name of the DLL, the export function. You remember the exports are the functions available from the DLL. And sometimes you can also even pass parameters. And that way you can call functions from the DLL, run it in the machine and see what it is doing. You can use some debuggers, Immunity Debugger, Only Debug, you will know those in the labs. And they have their own loader so that they can load DLLs and you just load it to the debugger and they do it for you by calling a DLL export that you want to run. Don't worry about this. It's going to be in the labs. Now, let's talk about tools, dynamic tools that you can use on your machine. We talk about sandboxes. We talk about all these things. That's great. Now let's talk about if you want to run the malware on your virtual machine, virtual box, what tools you can use to see dynamically what the malware is doing. The first one is a must-have, is Process Monitor. This was a tool created by Mark Rosinovich. Lately, this guy was acquired by Microsoft and now is part of the suite called Sys Internals. Here is the link, and it's totally free and available for you guys. Basically, what it does is it will monitor what the executable is doing in different angles. It's going to check the registry, if the malware is saving something in the registry. Normally, guys, when the malware stores something in the registry, is for the malware to execute after a machine reboot. That's mainly the idea. So you will notice if it is doing something in the registry. File system, obviously, if the malware is writing into the disk, reading something from disk. Threats level, if the malware is injecting into something else. Network level, if the malware is communicating to other IPs and ports. Now, very, very important. So you see this screen here, guys. When you run it, you will see in the labs, but it is just hundreds of lines. It's just too much information. So we will show you how you can filter out to focus on specific actions. Otherwise, you're going to get just crazy and get lost easily. Okay? Don't worry about that. We're going to teach you how to do this. A second tool is called Process Explorer, also from Sys Internals. The main difference between this and the one that we show you is that you can see at tree level the processes that are running in the machine. And to me, this is very, very, very useful for you to see when there is a process that is being infected. As you can see here, for example, you see this this color here, pink color. So, for example, if let's say that this Process Explorer gets infected by the virus, you will see right away here another color of another process being injected visually. So that's actually for me very, very useful to see how the malware is being seen at process level, and can also verify if it is legitimate, if it is signed, and some properties of the files. Useful. So, but that's mainly for me the way I use Process Explorer to see what other processes are being spawned by the virus. Registry monitoring, again from Sys Internals. What this guy does is it monitor changes in the registry so that you don't need to go to, as you remember, I was telling you, right, that there is a lot of information in Process Monitor. So with this machine, you get a snapshot before running the malware, and then after running the malware, and this guy is going to give you the differences. And that quickly, you can see what was the changes and quickly see if the malware alters something in the registry, Windows registry, okay? Traffic monitoring. Traffic monitoring is very, very important, guys, because at the end of the day, the malware, sooner or later, he needs to communicate to the CNC. He needs to talk to the attacker's servers. And you really want to know those domains and URLs because you really want to put traffic blocking on those destinations in your organization. That's very, very important because that way, in the worst case scenario that one of your machines or many of your machines are infected, if they cannot talk to the CNC, they cannot receive new instructions, and you have a chance to not being totally compromised. Okay, so that's why traffic monitoring is very, very important. And the first option is Wireshark. So Wireshark is a tool that runs in Windows and in Linux, and normally you run it, you put it in live mode, and basically it's going to start monitoring all the traffic that is running. Now, if you are running the malware and then Wireshark in the same machine, it's not recommended. I recommend you to have one machine with Wireshark, another machine with the malware in the same segment. It's the two virtual machines basically. There's a specific configuration there, and then that way the malware doesn't know that there is a network sniffer watching the traffic. Okay. Fake server. So you can have also fake servers. Why? This is very important, guys. Why a fake server, right? So suppose that the malware is gonna try to connect to internet, and the malware is gonna try to connect to an port 80. Netcat is a tool that is actually pretty cool. You will learn it in the labs, and you can tell Netcat, hey, listen to the port 80. So when the malware tries to talk to the port 80, you're gonna say, hey, I am here for you, and then the malware talks to you. It's not that easy, because then after that you need to understand what the malware wants to talk to you, and you want to keep faking it until you get information that you want. For example, if the malware is going to send out information from the machine, you can get with this faking all the information that is extracting and then understand what it's trying to steal. For example, sometimes it's easy, sometimes it's not that easy. Or you can also open up a HTTP server with Python. That is also pretty easy with one line, as you can see here. Those are like a fake, easy to set up servers that you can listen there waiting for traffic from the malware to connect to, okay? Pretending that you are the CNC server. Now, this is only port 80 and HTTP. But what if the malware wants to talk to other ports? And not only that, what if the malware also wants to expect some response from the server in order to keep interacting? That becomes more sophisticated. For that, we have tools like inetsim. Inetsim runs in Linux, and that tool, what allows you is to have multiple protocols that it can fake. Not only HTTP, but it can fake DNS, HTTP, SMTP, IRC, NTP, many, many different protocols, so that if the malware uses other protocols, it can also fake those protocols, and so that the malware can talk to it. Okay. Also, you can actually serve malware from the CNC. Let me explain this. Imagine that the malware connects to the server and says, hey, serve me the next stage for me to infect the machine. Okay? So you can fake that, serve anything that you want, and then the malware is going to think it downloads something from the CNC and running it. That is very useful for you as an analyst, so that you can understand what is trying to do with that file that is being downloaded. Okay, that helps you to understand all the process of the malware, and it records all the traffic coming in, coming out, because at the end of the day, you want to have this whole traffic. Okay, and here is how it looks when you run inetsim in a Linux box. It just gets all those ports open. This is basically you configure your Windows virtual machine to have a DNS, which is this Linux machine in inetsim, so that when the malware wants to go outside, and they not only the DNS, guys, the gateway is this inetsim. So when the Windows machine runs the malware, the way it goes to the internet is through the Linux box, which has this inetsim, and that way you can respond to the malware. Okay, that's a setup there that you need to do. This is only when you don't want the malware to go to internet and you want to fake all the traffic so that you can understand what it is doing. Because then you can also definitely want to let the malware go to the internet, because probably he's going to try to download the next stage and you want that next stage to analyze it. Okay. But my recommendation always is, before let the malware go and connect crazy, first do this, analyze what it's trying to do. Once you understand exactly what it is doing, then you say, okay, this guy wants to connect to the port 8080. Now I know it's going to try to download another stage and it's going to execute these 4 steps. Okay, I let it go, but I know exactly what it is going to be doing, instead of just let it go and you don't know anything of the malware. Okay. FakeNet is another project from Mandiant, which is actually pretty cool. This one runs on Windows. It's similar to NetSim. The only difference is that this guy supports fewer protocols, but it's the same idea. You run FakeNet and it's gonna fake the malware that you are the internet and it's responding with these protocols. And the idea is to capture traffic. At the end of the day, it's the same thing, guys. You wanna lure the malware so that it can talk to you and you can get all the traffic before heading to the internet live. Okay. Auto runs. This is also another from CC internals. This one is gonna help you to understand what is being running after rebooting your machine. This is called persistence in the malware. So let me explain you persistence. So when the malware runs in a machine, he wants to gain persistence because he wants to make sure that if for some reason the malware is deleted or blocked or removed, whatever, next time the machine reboots, it gets executed again. That way it gets persistence into the system. And the way the malware can be persistent is by doing many different tricks. One of the most common one is to store the executable in the registry key, in the Windows registry key. Okay, so that there are some Windows registry keys that every time the system reboots, they execute some programs, like services in Windows. So these guys add the malware in those keys so that they can get executed every time. But it is not the only place. There is a folder startup in Windows that if you put anything in that folder, get executed after reboot. So at the end, auto runs is going to allow you to look up into those different places, registry keys, shell extensions, toolbars, and it's gonna all these, you see these WinSock, LSAs, codecs, boot execute, image Ajax, Internet Explorer, all those guys are places, scheduled tasks are places where the malware can hide to be auto executed in the next time. So auto runs is gonna help you to see and give you a view quickly so that you can identify where the malware is hidden. Okay, guys. So that's pretty much it. As a summary, we talk about important terms of this field in the glossary. We talk about the different malwares that you guys now know, spreading techniques, how the malware can reach the inbox, how you can set up a lab to do the analysis with virtual machines, the tools that you need to do for dynamic analysis, how you can configure the virtual machines for that, how you can perform analysis. Again, guys, don't get worried. This is not like that's done. This is just high overview. Everything that you see here is going to be in a lab. You're going to practice and you're going to learn. Okay, this is just for you to get a shot of what is being done, and how it's been done is the next one. Okay, take care.